In this episode, we talk about business models in the hydrogen industry, for example, for manufacturers of electrolyzers and about the customers to owners and operators of the hydrogen industry. And someone who has been very intensively involved with this topic is Philipp Glaser.
Get ready for Hydrogen, a Siemens podcast with Michael Pretorius and Philipp Glaser.
Philipp, what new business models are emerging here right now?
We have the exciting situation in the hydrogen industry where indeed very different players, especially manufacturers of electrolyzers, are entering this market with diverse backgrounds. Some have a long history in the process industry and may have already done other things in the field of electrolysis. We have those who come from other industries who are now reorienting themselves in new business fields within the framework of transformation in mechanical engineering and automotive, and are thus entering the field of electrolysis because hydrogen is naturally a growth market. At this point, we also have many small and micro enterprises that are entering this market as startups, and they are coming, whether they come from the experienced, those from other industries, or the newcomers, they are indeed entering a market that is not yet fully mature, still very impressionable, where the interaction between the different parties in the construction or operation of a plant is not yet as well established or settled as it is, for example, in the chemical industry. And this naturally allows for a lot of flexibility. It also allows for occupying business models and shaping the market. And in doing so, we want to support, for example, the manufacturers of electrolyzers, as well as their buyers, their customers, and their investors.
An electrolyzer looks relatively simple. You have to imagine it a bit like a construction container filled with a lot of stuff from you. Ultimately, the exciting part is the digital components in such an electrolyzer when you take advantage of this momentum from the beginning to build a digital hydrogen plant. What new data-driven business models are emerging here?
So the electrolyzers are almost all very innovative products that are currently coming onto the market. Many electrolyzers manufacturers are currently at the stage where they have built their first pilot plants in recent years or months, or have built pilot electrolyzers, perhaps a technical plant in a laboratory, and may have already delivered the first electrolyzers to customers who operate them in smaller plants, in smaller applications. This also means that we have, in principle, very few companies that already have decades of experience in operating their hydrogen plants, respectively their electrolyzers. And at this point, it is indeed naturally interesting how this scales to larger capacities because the requirements become much higher there. The demands on integration increase. An electrolyzer is indeed a complex component in its intricate design and operation. If I have 10 or 20 electrolyzers standing side by side to achieve higher capacities by numbering up, then they must of course be integrated in some way. However, they also need to be maintained, they must be able to be operated safely. And of course the question is, how can I make it as simple and easy as possible? If, as a manufacturer of my electrolyzers, I am now able to have done this with a digital twin, to have a digital twin of the whole thing because I have used the right tools, then, of course, subsequent numbering up during integration for the plant builder or the owner-operator is very, very easy because they can incorporate it into the engineering with drag and drop. Certainly, it is undoubtedly a significant advantage for the electrolyzer supplier in this competitive market. Currently, the market is very large and there are few electrolyzers available, or this number is likely to increase, but the competition will naturally become much, much stronger there as well. On the other hand, I need an integration of the electrolyzers into the system because the electrolyzers are not a simple component, they have high complexity, and at the same time, the electrolyzer manufacturers also want to protect their know-how and intellectual property. This means we need integration into the overarching system, into the overarching automation at the customer's site, but we also need the ability to protect know-how. That's the framework. Now the question is, what kind of business model can I develop from it? For example, the question is, who actually maintains these electrolyzers? Who ensures that the electrolyzers are operated as they should be so that we don't encounter a problem later on? For example, there might be some difficulties with the membrane, and there could be a discussion about whether it was due to the material, the construction of the electrolyzers, or the operation of the electrolyzers.
So you want to operate the whole thing gently on materials?
Exactly. So if you operate it, let's say, without regard for losses, then you indeed have a much higher wear, for example, on the membrane. And if the membrane were to fail relatively quickly or encounter problems relatively quickly, then the classic discussion would naturally start about whether it was due to the material or the operation. And indeed, precisely at this point, there is now the possibility, if we use the digital hydrogen plant and apply digitalization at the level of the electrolyzers, and also use our hydrogen performance suite, with which we can manage an entire fleet of electrolyzers, then, for example, there is the possibility that an electrolyzer manufacturer might say, well, it doesn't matter at which customer my electrolyzer is located. I am delivering 5 electrolyzers to customer A, 10 electrolyzers to customer B, and 20 electrolyzers to customer C. And although these are all different customers, I still agree that we, as electrolyzers, can continue to monitor these electrolyzers so that we receive a certain amount of data. From electrolyzers, I have my fleet management in the hydrogen performance suite, allowing me to monitor them, determine how they are operated, and perhaps learn what the optimal way of operation is for the best performance with a material preserving approach. I could do all these things with the data.
I will now try to find an example or make a comparison with the automotive industry because you said it is a startup market with very little experience. I will simply compare it to driving a normal car uphill in second gear with the handbrake on. I will quickly see in the data that this was not such a great idea. At the same time, I will also see that when I go downhill with a tailwind, the thing just runs better. This is spoken very simply now. This also means that with my first electrolyzer that I built, a lot of data will be generated regarding the efficiency of this system and material conserving operation. Can I now directly apply these experiences to my other electrolyzers that I have built later or will build in the future, just like with numbering up? Or did I simply pay this learning cost at the beginning and cannot transfer it later?
So, let's stay with this nice example of the automotive industry. If we continue with this example, this metaphor, we would have the situation where if you are driving up a hill with a very unfavorable gear configuration, it would be conceivable that the manufacturer of this vehicle might display a message suggesting you should switch to third gear. Your clutch, transmission, or something similar might eventually break down in the medium term over time. And if you, as a customer, come to the auto repair shop, let's say, you might also have the problem that the person at the shop says, well, this vehicle has never broken down after 20,000 kilometers. You must have driven up the hill in second gear. But if you could now show, no, I'm not, because we have a shared databases that we share at this point, and we can see that the car never went up the hill in second gear, that's exactly where you would have this benefit. In principle, similar things are happening in the automotive industry. Nowadays, the automotive industry has connected cars, meaning that a large part of the car manufacturers today collect diagnostic data and similar information from these vehicles, of course anonymized and similar things. Yes, we process this data as learning effects for the next generation, for the facelift, for the next update and upgrade. And it is precisely this capability that we can provide to electrolyzers with the digital hydrogen plant. That also involves a lot of risk. Just think, I am now a relatively new player in the market for electrolyzers. I always think, wow, what a risk. I am a new company and I might still have a high level of external financing involved. And now I am starting to travel to different countries in different regions, relatively far from each other, where I might not be able to just get there in 2 minutes. Now, if I deliver various of these components, sometimes 5, sometimes 10, sometimes 20 or even more, to operational plants, and if there is a problem, like a recall in the automotive industry, it can indeed have existential consequences for such a company. That means it's also a form of control. And I can see that some are starting to say, for example, I only deliver my electrolyzers if the customer signs a maintenance contract with me. So, for example, some kind of operation and maintenance contract. And for this operation and maintenance contract, I might offer 3 different options. And I agree, so you get my electrolyzers at that price, you can buy it at that price, but then you also have to sign a maintenance contract for X euros per month, And in this maintenance contract, it states that I, as the manufacturer of the electrolyzers, have access to these electrolyzers and can extract this and that, monitor data, or can extract this additional and relevant diagnostic data from the facility. You, dear operator of the plant, dear owner of this plant, must accept this if you buy my electrolyzers. On the other hand, you have the advantage that we take care of maintenance, that we provide you with tips for the best performance, for the most material-friendly operation of the system. We can support your employees in carrying out simple maintenance tasks for the major maintenance tasks. We can come to the plant, I don't know, quarterly or however it works. With so many hours notice we can be at your plant. Such things can certainly be contractually agreed upon and create a mutually beneficial situation for the manufacturer, as it removes risk from potential warranty claims. He has additional revenue opportunities and also the potential possibility to potentially play a corresponding role in maintenance. By the way, I believe the effect should not be underestimated. Electrolyzers also want to encapsulate their intellectual property. This means on one hand, they must enable the customer to integrate into the system, and on the other hand, protect intellectual property. The more I protect intellectual property, the less data the operator of the system has. This also means that as a manufacturer of electrolyzers, I must naturally help the customer, because if they have less data, they need a certain amount, since legally speaking, the operator remains the owner in the end. And the operator of the plant is always the one responsible for the safe operation of the plant.
That sounds like a field of tension that I would like to delve deeper into. When you talk about this intellectual property, what knowledge advantages arise with electrolyzers? Because ultimately, these are all data that, I would say, arise somewhat like a byproduct from this momentum, as it is a digital twin.
Exactly. So, electrolyzers, for example, do not have a linear performance curve. So, depending on how much power you put in, what comes out is not a linear curve. This means that the first thing is, of course, to understand and monitor these performance curves. For example, if I have 10 electrolyzers and I am running the plant at only 70% capacity, the question is, do I perhaps run 7 out of 10 electrolyzers at 100%, or do I run all of them? 10 electrolyzers at 70%? These are the questions where, for example, you need to have monitoring of the performance curves accordingly, or rather, how do different production programs and operation modes exactly affect the degradation of the membrane? Have we already talked about measuring or capturing that with soft sensing? Can calculate from the comparison of simulated data to the actual data from automation? These are two striking examples of what I can do with data in this context, and in essence, what a truly win-win situation between the owner and operator of the plant and the manufacturer of the electrolysis system can indeed bring about significant improvements into this system. When I come back to automation, to this topic of black boxing, it is something that must be very individual. We can offer the customer and the electrolyzers all possible variations, so to speak, from making it very simple by putting a controller in each electrolyzer and considering each electrolyzer individually. Then, of course, this integration is somewhat more complex because I have to figure out how to ensure safety and similar things. When I am in a larger plant, for smaller ones, this is often completely sufficient. When there are several, this integration into the topic of emergency shutdown and similar things can become very, very complex. Up to full integration, meaning the controller is fully integrated into the control technology of the plant operator, and even then, of course, I have the optimal integration into the system, but even then I can still control which values I, as an electrolyzer manufacturer, can see and which values the plant operator can see. And even with full integration, I can, of course, still have a wide range of options available, especially when considering our own systems, SIMATIC PCS7 or SIMATIC PCS Neo, to protect intellectual property. This ensures that the person operating the plant cannot access everything, potentially share it, and so on. So we always like to take a closer look at, with the electrolyzers manufacturers, examining them thoroughly. Sometimes it has now increasingly happened that we sit together at a table with everyone. So the electrolyzer manufacturers, the plant operator, and sometimes the plant constructor, the EPC, sit at the same table. And we have already looked at this individually, with different interests and preferences for different architectures. which architecture is the one that satisfies everyone the best. In the end, most benefit from it because for one, it's competitiveness, for another, it reduces risk, and for another, the integration is the highest. As Siemens, we can handle all these variations and are almost like an independent advisor when we sit at the table and can advise this network of suppliers and users.
This ultimately means that the owner and operator of the plant, who ultimately operates it, could ultimately do all these things themselves. However, through this collaboration based on this data, he can naturally delegate many tasks that might not be his area of expertise.
Yes, but also no. For example, if he now had an electrolyzer that was completely as a black box, let's say, worst case, assuming the worst case, there is an electrolyzer that is completely boxed in within this box. The thing operates independently, is automated on its own, and in case of doubt, there's just a bus cable sticking out. And this bus cable now primarily empowers the possibility, through connectivity, to switch on, switch off, and perhaps see a few values. That might not be enough for the operator of the facility plant, as you say, to do everything themselves, because they might be missing important data and information that they, for the maintenance, repair, and for the safe operation, actually needed. You would struggle if you are an independent workshop and a car of a certain brand comes in that you don't know, and you have no way to connect to the diagnostic system of this car. Then you would probably, I'm not an automotive expert, but I imagine it would be difficult nowadays. If a car comes into the workshop and you can't connect to the diagnostic system, what is the problem there?
But to make the comparison, it would be like if you take this black box and then for the owner-operator, a yellow warning light simply comes on, telling them to get in touch with their maintenance person. In the other case, they not only see the yellow light blinking but also know exactly, the membrane is the issue.
Exactly, and in principle, one could then call their electrolyzer service center and ask what's going on because they can see it due to this connectivity. Or rather, we would actually assume that we wouldn't even get into this situation because, of course, through this connectivity, through the use of data, through the topic of anomaly detection, through the topic of asset performance management, asset management, we would already recognize in advance with all the knowledge he has about his electrolyzers, because he has this connectivity, that we are heading into such a problem and would already act proactively by telling his customer, hey, watch out, you need to do this and that. Or, I'll send someone over next week to check on this and that component.
I gather that the business model will be to have long-term, very intensive customers who are sustainably and consistently renewed based on comprehensive data analysis. And if you want to delve deeper into this topic, then subscribe to this podcast and also listen to the other episodes. Thank you, dear Philippe.
This podcast was done by humans but localized with the help of AI. Thanks for listening.